Today we're working some sample problems from section 3-4, and those problems begin on page 124 in the book. And we'll begin with number 6. It says this one's about earthquakes. Data set 16 in Appendix B lists 50 magnitudes on the Richter scale of 50 earthquakes, and those earthquakes have magnitudes with a mean of 1.184. And a standard deviation of 0.587. The strongest of those earthquakes had a magnitude of 2.95. Okay, and we have a series of questions. What is the difference between the magnitude of the strongest earthquake and the mean magnitude? So the magnitude of the strongest minus the mean magnitude gives us 1.766. Okay, part B, how many standard deviations is that, the difference found in part A? So we want to take 1.766 and divide it by 0.587, and that's 3.01. Alright, convert the magnitude of the strongest earthquake to a z-score. Okay, so for z-score we want to take our x, which is the strongest magnitude, minus the mean magnitude, and divide it by the standard deviation. Remember our z-score formula, x minus x bar over s. And actually, that's what we just did in parts A and B. We simplified the numerator and then divide it by the standard deviation, which gave us a 3.01. Okay, part D. If we consider usual magnitudes to be those that convert to z-scores between -2 and 2, is the magnitude of the strongest earthquake usual or unusual? Well, because it's greater than 2, it would be unusual. Okay, let's move to 11, which also deals with earthquakes. The Southern California Earthquake Data Center recorded magnitudes Richter scale of 10,594 earthquakes in a recent year. The mean is 1.240. And the standard deviation is 0.578. Consider the magnitudes that are unusual. What are the magnitudes that separate the unusual earthquakes from those that are usual? So we're considering usual again to have a z-score between 2 and between -2 and 2. So basically what we're going to have to do is solve an algebraic equation, x minus the mean divided by the standard deviation. We want to solve for that x, and we also want to solve for this one. Okay, so starting with the one here on the left, if I multiply both sides by 0.578, this fraction here by 0.578, that's going to clear my fraction, and that's times here. -2 times 0.578, I get -1.156. Then if I add the 1.24 to both sides, I get, and I'm going to go in this direction, since I've got another problem to work. Plus I have the negative 1.156 plus 1.24 gives me 0.084. And this one I'm going to multiply by 0.578 as well. 0.578. And that'll cancel. Over here we're going to have a positive 1.156. And I may be running out of your viewing. And then we're going to add the 1.24. So we get 10, whoops, we get 6, 9, 3. I'm getting 2.396. So it would be between 0.084 and 2.396. Okay, let's go to 14. I'll try not to run off the page this time. As of this writing, Sandra Bullock was the last woman to win an Oscar for Best Actress, and Jeff Bridges was the last man to win for Best Actor. At the time of the award ceremony, Sandra Bullock was 45 years of age, and Jeff Bridges was 60 years of age. Based on data set 11 in Appendix B, the Best Actresses have a mean of 35.9 and a standard deviation of 11.1. The this is actress. The Best Actors have a mean age of 44.1 and a standard deviation of 9. All right. Relative to their gender, who was younger when winning Oscar, Sandra Bullock or Jeff Bridges? Okay, so we have and Sandra was 45, he was 60. Okay, so we want to compare their z-scores. So 45 minus 35.9 divided by 11.1. Okay, so 45 minus 35.9 gives me 9.1 divided by 11.1, and I get 0.82. Okay, for Jeff Bridges, I'm going to take 60 minus 44.1 and divide it by 9. Alright, 60 minus 44.1 is 15.9 divided by 9 is 1.77. Okay, so that means Sandra Bullock was relatively younger than Jeff Bridges because she had a z-score of 0.02. Whereas his z-score was 1.77. Okay, on the next page we have a series of numbers. Stay inside the lines here. Let's see, whoops, I should only have, okay, 250 is my next one. 250, 251, 252, 254, 255, 259, 260, 266, 269, 273. I am missing one. 120, 178, 213, 234 is twice, 235, 237, 240, 243, 245s, 250s, 251, 252, 254. Ah, here's where it is. Two 255s, then a 259, 260, 266, 269, and 273. Okay, now I've got it. All right, we're using all of these numbers in the next group, so I'm going to do a couple of these. Let's start with number 18. It says, use the following duration times of 24 eruptions of Old Faithful Geyser in Yellowstone National Park. The duration times are sorted from lowest to highest. Find the percentile corresponding to the given time. So the given time is 240 seconds. So what we want to do, here's 240. We want to count the number less than 240, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's where I'm getting the 100/3 from, so 33.33. 33rd percentile is what I'm coming up with.